Hey everybody, this video is going to be a video about testing, repair, maintenance of the RFC series of welding pedals. These would be the pedals that would come with either a welder like a Miller 330A/B/P or a Airco Model 3A/DDR or some variant of those letters and numbers. I don't remember off the top of my head, but generally speaking, these pedals are they have a part number on them that has a prefix of RFC, and you might see different numbers on the end, but they're all basically very similar in construction and operation. So I'm going to talk briefly about the theory of operation of the pedal and how it actually interacts with the welder, because it's very different than a modern inverter welder as far as operation goes. And then what we'll do is we'll do some quick tests to assess. I actually have two of these pedals. One of them came with my Airco welder, and the Airco is basically, it's a carbon copy of the Miller 330. And the other one came with another similar Airco welder, but that welder, I bought that one strictly as a parts machine, and I bought it for the leads and some other stuff that came with the welder, and scrapped the rest of it because that was a three-phase only. I know it could have been converted, but it was a three-phase DC only welder, so it wasn't of much use to me. But I'm getting off the subject. But that was the other thing that came with that welder, was a pedal. So I actually have two pedals. I don't need both. If you go to buy a replacement used pedal off of eBay, they trade north of 125 bucks. So if you can repair or rejuvenate your existing pedal, you can save yourself some coin. So that's why this video might be helpful. And if not, well, then you're gonna have to go to eBay and look for a used one and be victimized by someone like me, who's gonna put up my extra pedal for sale more than likely. All right, enough of that. Let's get on with the video. Let's start by taking a look at my welder. This is my Airco Model 3A/DDR 245, or is it 2A5? I don't remember. HPA/B-D. Now, don't get too hung up on all of these nomenclatures on the end there. If you want to spend hours finding information for this welder, just simply put in an Airco Model 3A and let your fingers do the walking. But essentially, this is, in its many different variations, essentially a Miller 330 A/B/P, I think is the Miller number. But essentially, you can see this same exact welder in the Miller colors of blue. So this was made by Miller, but marketed under the Airco name at the time when this welder was made. There's several different variations of this welder. Also, other little differences down below here. There's a post-flow module. On earlier versions, it was an electromechanical post-flow timer. I think that later models had a solid-state timer. Mine had the mechanical, and I changed it over, and I did a whole video on that. You can just search my videos for Airco welder, and you can actually see the videos of me scrapping the other one and all kinds of stuff. But anyways, a lot of people are like, oh boy, what a ancient dinosaur. What the hell would you do? Why would you want even something like that? Well, because I can't get or afford the nice Miller inverter TIG, with all the fancy features and everything. And I'll tell you what, there are a lot of professional people out there that are doing really good work and are still using this unit or the Miller counterpart of this unit. And I'm not talking about just weekend warriors on YouTube. I mean, I'm talking about guys that are doing this for a living. The number one negative thing I can think of for this welder is that it weighs in north of 800 pounds. So that makes it kind of difficult. It's physically large, so it takes a large footprint. This thing, if you took like a freezer chest and stuck it up on its side, that's probably about the footprint that that thing's taken up. And again, like I said, the incredible weight. It's probably a power hog, although it's not like I'm running this thing all the time. So, all right, so that's enough about, you know, there's plenty, if you want to go and find out about the welder, there's plenty of information out there. You can check out Welding Web and other sites like that. So, let's talk about the pedals. So these are my two RFC pedals that came with the two Airco welders. Now, interestingly enough, the one on the left, which is gray, is actually badged with the brand name Airco. So you can see this what's left of an Airco sticker on there, and it's a model RFC-23AG. This one here is in the classic Miller blue, and that's marked model RFCS-23, and that's the only markings I can really find. Taking a look at the back side, you could really get an appreciation of just how close these are to each other as far as similarities. They practically have the sticker, the warning sticker is almost in the same exact location. You'll notice this one has two cables coming out. This one only has one cable coming out, but it's got a place for the second cable to come out. I'll explain that in a moment. But the way these operate is virtually identical. So these two connections, these two plugs right here, are where this pedal interfaces with the actual welder. These types of plugs that are on here are actually different on different models. But on all of these welders, you have two plugs. And then it's a matter of whether or not you want to use a cable with enough conductors in it to allow you to have one cable running to the pedal, or like in the case of the gray pedal that I just showed you, there are two separate cables that run out to two plugs to plug into here. Now that gray one won't plug into here directly, only because the types of plugs are a little bit different, so it won't mechanically plug in, but it would be just a matter of actually changing these plugs over to the wires, and there's no reason at all that that pedal couldn't work perfectly fine with this particular welder. The pedals actually do two separate jobs at the same time, or in unison. One thing that the pedal does is it has a switch inside that when the pedal is depressed, you can actually hear a click. When you start to depress the pedal, even the slightest amount, there's a click. That closes a switch, and that switch will stay closed no matter how far down I press the pedal, until I back off to almost completely, and the switch will open. So essentially, it's an on-off switch inside there. The second job that's being done, so one of these cables is strictly for on and off. It's either making connection or breaking connection. The second cable goes to a device inside here, which is a variable resistor. And what that item does, it's on more modern pedals, they probably use a potentiometer. On a pedal like this, they may use something called a rheostat, but we'll get to that when we get this apart. What that other device does is that device has a specific electrical resistance, and that electrical resistance is varied by a mechanical linkage here. So when we take it apart, we'll see how that works. But essentially, the further down I press this pedal, the more it's going to change the resistance. So depending on where I have this pedal pressed, what position it's in, I'm going to have different resistance. It's going to have a different electrical resistance that it presents to the control circuit. So this is where it can get kind of confusing. This is a 300 amp welder, okay? And you might think that all of the welding current actually somehow passes through that pedal, and naturally, first question would be, well, how could that possibly be? How are they allowing this skinny little, that's the contractor control, this little skinny wire that's inside here, how the heck are they allowing that to handle all of that current? Well, they're not. And essentially what's happening is inside here, there is a control circuit. And what that control circuit does is it uses a smaller, lower voltage and current on a special winding on the main transformer to actually affect the magnetic field in that transformer and to increase or decrease the current flow in the secondary of that transformer. The secondary of that big huge transformer, it's either rectified for DC or it's sent straight out for AC. And that big transformer is being controlled by a smaller voltage. And that's actually a very common scheme that's used in any number of different devices. Those of you who've ever had a motor speed control that used a device called a silicon controlled rectifier, or SCR for short, essentially it's a very similar situation. They're using a smaller voltage on one of the legs of that device to control the higher voltage going to the motor. Light dimmers, they work in a similar way. Trying to think of some of the other things that come off. Actually, even an audio amplifier, your typical stereo, what's happening in the output section of a stereo amplifier is you've got larger output semiconductors that the waveform coming out of the output is being controlled by a much smaller waveform applied to, typically if it's transistor output, the base of the transistors. And you know, I'm getting way off the subject. This one you can see it says contactor control. This is going to go to that on-off switch inside there. And this one right here, it says remote amperage control. This is going to go to that control circuit. When certain switches is thrown in certain positions right here, it determines whether or not the pedal has activation. So for instance, if I put this in standard and standard, what happens is the switch on the pedal no longer will control the contactor. If I put this in standard, as soon as I power this up, the contactor closes and the leads are live. If I have it in remote, when I power this up, the contactor doesn't close until I step on the pedal. The amperage control, if I have it in standard, it allows this amperage control on the front dial to actually control the output current. When I put it in remote, now the pedal actually runs the show. So now I'm just going to talk about some of the potential problems that a defective or intermittent pedal can cause, and just a quick way to diagnose whether or not you've got a pedal problem or something else going on. So the first part of the pedal that can give you trouble is that switch I talked about. That switch basically only has two states, either on or off, or at least it's supposed to. If you have a problem with that switch, what can happen is when you step on the pedal, the contactor won't close, and of course nothing works. So you could have literally, the welder could seem like it's not working at all. But it's real simple to diagnose that. All you're going to do is come up here to your contactor control, your switch, flip it over to standard. You flip it over to standard, you should hear that contactor close. If you flip it over to standard and your contactor's still not closing, there's something else going on that's wrong inside the welder, and your pedal's not your issue at that point. Not saying that that doesn't mean you might not have issues with your pedal also, but you've got to resolve that issue inside the welder first. So if you're finding that when you flip this to here, you don't hear that contactor snap shut, you might as well just stop watching this video and move on.
But let's say in this particular case that you find that, boy, you know, that contactor snaps shut when you put this over to standard, but when you put this back over to remote and you step on your pedal, it's not closing. Well, then chances are you've got a problem actually somewhere between the plug and the switch inside the pedal itself, or the wiring in between. And we'll get into diagnosing that a little bit more in a moment. The other problem you can have with the pedal is maybe that switch section's working okay, and the pedal is the contactor's closing and opening when you step on the pedal and release the pedal. But maybe you're having all kinds of strange problems with amperage control. Now, the majority of the time, that's going to be something going on inside that control circuit inside the welder. However, the other possibility is you could have a problem with the actual rheostat, the variable resistor that's inside that pedal, or the wiring in between. The way that I would suggest diagnosing that is, once again, I would come back here, I would switch my amperage control to standard, and I would dial up an amperage, and just for testing purposes, you would have no amperage control, but you could still draw an arc and run some beads and see how it's acting. If everything seems okay, but then when you flip it back over to remote, you can't seem to get amperage control with the pedal, then I would suspect possibly a problem with the pedal. And again, now we're going to take these over to the bench, and we're going to diagnose them on the bench. All right, let's talk about testing the easier part of the circuit first. The simple open or closed switch. The switch that only has one of two states that it should be in. Either open, which is infinite resistance, or closed, which is very low resistance. So I've got, on this one, I've got the two cables here. I know that this one goes to the amperage control. So I know that this will actually go inside to the rheostat, or the variable resistor. This one goes to the contactor control, so I know this is the one that goes to the switch on the inside. You'll notice there's three prongs. One of the three prongs is not used. Now you can either, through process of elimination, you can determine which one is the two that are used, or if you're actually getting no activity at all, what you might have to do is you might have to actually open up the box here and trace which wires go to the switch, and then open up the plug here and see which color-coded wires go to the which prongs they go to, and you can figure it out that way. Chances are one of these isn't connected at all to anything. But I've got my alligator clips hooked up here, and I've got my Fluke 87 DVM. Now all you need is a very simple multimeter to do this test. You can use a $10 Harbor Freight cheapo multimeter. I actually prefer an analog meter with a needle pointer for doing the other test we're going to do, but for the sake of being fairly expedient this evening making this video, I'm not going to go digging out. My only analog meter I have is my old vacuum tube voltmeter, which is really fun to look at, but I haven't used that in so long I don't even know if it'll work. So we'll just go with the trusty old Fluke. So I've got this set actually right now. I have it set to the resistance scale. First test I'm going to do is I just if you've got a continuity checker buzzer, you can turn that on, and when I press the pedal, so that looks pretty good. The second test I like to do is I like to we'll just shut that off. Just want to look at the resistance, the electrical resistance that we're getting. So the first thing I usually do, especially if the meter hasn't been used in a while, is I'll short my two alligator clips together, and you'll see I'm getting about 3 ohms. That's actually a little high, and sometimes it's just a matter of reseating these plugs. 3.5 is about probably as good as we're going to get. That could be, yeah, we've probably got these little cheesy alligator clips, aren't so great. Might have some corrosion on the plug there. Yeah, I can get it down to, there we go, 2 ohms. All right, so I'm going to get this, hook this back up, and I'm going to close the pedal again, hit the switch, and you'll see I'm getting about 4.6 ohms. So if I'm getting 2 ohms just with the leads, 4.6, I'm really measuring 2.6 ohms of resistance. That's actually pretty darn low. What I'm measuring is I'm measuring all of this cable, the electrical resistance of this entire cable, and any connections inside there, and that's all pretty normal. The other thing you can do is, not a bad idea, again, maybe with the continuity checker on, we can, if we can place the cable in proximity so that we don't knock the leads around, like I just did, and knock the alligator clip off. All right. What you can do is you can step on the pedal, and then while you're stepping on the pedal, you can shake and wiggle the cables, especially at the points where like they go into right here on the box or right at the plug itself. And if you get any erratic behavior on your connection there, you might have a break or a bad connection at those points, and then you're going to want to investigate that. You might even end up having to completely redo the connection, strip it back to good clean wire, and reconnect it. If you're going to have a problem like that, typically you're going to have, if the cable's damaged somewhere, obviously, but typically it'll be at the plug end here. This can get whacked around. Somebody in the shop trips on the cable, gives it a good yank. Over time, it can cause a problem there. On the pedal end, this particular one here, it's actually got some strain reliefs, so they do a pretty good job of protecting this. So if you've traced your wires and you know you're on the correct wire connections for the switch, and you're still not getting continuity when you close that switch, well, then you're going to open up the pedal, and we're going to get to that in a moment, and investigate. And you want to get those leads for your meter connected directly to the switch, and then activate the switch and see if it doesn't close. So we're going to assume that everything's okay there, and we'll revisit how that all works once we get the pedal apart. But right now what I want to do is I want to shift gears to the more problematic part of the pedal to actually correctly diagnose and verify. And the reason why that is because instead of just 2 states of on or off, we're actually looking for quite a variable resistance to be happening depending on how this pedal is pushed. And what you can have is you can have a completely open circuit where no amount of pushing on the pedal changes the resistance at all, and it's just infinite all the time. You could have a short where you end up with just very low resistance all the time, no matter what point the pedal is pushed in. Or, my favorite, the intermittent. And that's where, as you start to push the pedal and the resistance starts to change, there should be a fairly smooth change in resistance that corresponds with the actuation of the pedal. But what you can have is you can actually have a bad spot in that variable resistor where it can actually cause it to make or break connection at certain spots. You can have what they call a dead spot, or you can just have corrosion or something else going on in there. You can have intermittent, so you could have a situation where the resistance starts going up or down depending on which way you're pushing the pedal, and all of a sudden it suddenly changes. You can imagine what kind of havoc that could wreak inside that control circuit on the welder, and what the output current is going to fluctuate like. It's going to be all over the place. So here's a good example of why I like the idea of having a analog meter to diagnose and test a variable resistor like this. Right now I've got this hooked up and I'm not touching the pedal at all, and you can see I'm getting about 88 ohms. And what happens is, as I press on the pedal, as soon as the switch closes, the resistance drops to 21.9 ohms. Now as I slowly depress the pedal, that resistance is changing. But you'll notice it just kind of went up and then went back down again. And there you go, it just did it again. Went up and went down. It's acting very erratic. And now I've got the pedal pretty much pushed all the way down. So let me check and see if maybe I don't have the right connections here. Maybe I'm on the wrong part of this thing. So that's very low. That doesn't seem to make a difference. So let's try here and here. Well, those two connections right there, they don't seem to make a damn bit of difference at all. Yeah, so I don't like the way this is acting at all. This assembly couldn't be easier. Got some mouse poop in there. Ooh, look at that animal. So even though we're using a lower voltage and current to control that much higher 300, possibly up to 300 amps of output current, there's still quite a bit of current flowing through here, which is evident by the fact that they're not just using some wimpy old potentiometer in here. They're using a rheostat, and essentially this particular type of this is typically a rheostat is a round device that has a wiper on it that moves around a circumference. Essentially, this is doing the same thing, only what they're doing here is the part that is stationary is actually a large wire wound resistor. So what you've got is you've got a coil of wire, okay, and the wire has a certain amount of resistance, and they wrap that coil around the post, and then what they've got is they've got a wiper right here, okay, that is probably a carbon button. And what that carbon button does is it rubs along this resistance here, and the location that it is on is directly proportional to the resistance. So in other words, you've got three connections here. You've got a wire at one end, a wire at the other end, and then a wire on the wiper. So this one is called the tap, because the tap is the one that moves, varies. To test this device, the first test you want to do is you want to go right from here to here, and you should have a fixed resistance. If this is open from here to here, if you get infinite resistance when measuring from here to here, this device is bad. So I'm across this device right here, and I've got a resistance of 16 ohms, and that resistance is rock steady and does not change no matter which position I put the pedal in. So that tells me that this resistance, this resistor, is not open, so that's good. So if we look closely at the actual mechanical part of the pedal, essentially all that's happening is when you push down on the pedal, okay, this arm right here is pushing down on this side of this arm, which has a pivot point right here. The back side of the arm has this little metal leaf extension, and what this extension does is it actuates this switch. Now the switch, oddly enough, is actually when the pedal is not depressed, the switch is being closed. And then as you depress the pedal, this bent piece of metal moves out of the way and allows that leaf switch to pop out. But it actually closes the switch, and the reason why is because this switch is of a design, it's called a double throw switch. It actually has a common terminal, and then typically they'll have two other terminals. One will say normally open and one is normally closed. So the way this switch works is that when this is depressed, it's actually open, and when the switch is allowed to pop out like this, it actually closes a contact. So if you were having a problem where you weren't getting, the contactor didn't seem to be working when you hooked up the meter to the leads at the end here, you'd want to come in here and you'd want to go right on this switch, and you'd want to take a measurement right there of resistance and actuate it and see how it acts. And if it still doesn't work, then you've got a defective switch, and you'd want to actually take the part number directly off this switch and see if you can't source something based on that part number. And if that doesn't work, then what you want to do is you want to find a switch that has the same rating. There'll be a rating on this switch. I'll try and get that. All right, now there's nothing wrong with my switch, but I removed it because the part number is on the back side of the switch that I couldn't see, and I just wanted to get this part number to anybody who might need it. This is a B as in Bravo, Z as in Zulu, -2, R as in Romeo, W as in Whiskey, 822. And this is a micro switch. These are very common, used in industrial applications. As a matter of fact, even in something as ubiquitous as your microwave ovens typically have micro switches in the door interlocks. And as a matter of fact, in a pinch, I bet you could use a larger microwave oven switch, because this is rated at 15 amps. So it's not super high current, but it's also not, super low either. So 15 amps is decent current. That's not what's really flowing through here, mind you. That's the rating is 15 amps. It's probably significantly lower than that when it's actually operating. But if you want, you could actually buy the exact switch right here. This switch is still available. If you Google that part number, you'll find several sources. I happen to like Mouser Electronics for a lot of my components. I've ordered from them in the past, and they show that they have over 700 of these switches in stock, I think, ready for shipment. And if you're only buying one, it's going to set you back about 20 bucks and change plus shipping. So it's not a super cheap switch. And again, like I said, if you really needed to get by in a pinch, you could probably retrofit a microwave oven switch in there. It just would be it would take a little bit of finagling to do, but I'm sure it could be done. This actually has what's called a 1-inch roller leaf on it. So this little bar right here, probably from the pivot point to the end here, probably measures about 1 inch. And then you've got this little roller here. And that's basically it. It's a pretty simple switch. You can actually see there's that other connection I was talking about. So this down this end here is probably going to be the common connector, and then this one right here is probably going to be the normally closed or normally open, I forget which. And then this other one that's not being used right here is the other side of the contact. So it is a double pole, I'm sorry, not double pole, double throw switch. Now during my initial testing, I was wondering what the heck was going on. Why was I getting one resistance with the pedal not depressed, and then when I first started to depress the pedal, the resistance suddenly changed? And I could see why now. There's actually almost like an area here, a band right here, that carbon brush parks on, so to speak, when it's in the unactuated state. And then as I start to push down on the pedal, you'll see that the carbon brush comes off of that metal band, which, by the way, the metal band consequently is common with this point right here. So that right there tells me that when this is not being depressed, what should happen is I should be getting very low resistance between this connection and this connection. And if I'm not, that would indicate right off the bat that I've got a problem with that carbon brush. So now I've hooked my lead, one of my meter leads, directly up to this connection on the resistor. And I'm going to take the other lead, I'm just going to touch it to that band. And you can see my resistance goes down to very low, only about 1 ohm. Now I'm going to come over to this connection right here on the brush. And look what I've got. I've got 43.2 ohms there. So you could have corrosion here causing a problem. You could have corrosion there. Or you could have a problem with the brush itself. So there's actually a way to adjust the amount of basically the amount of tension that the brush is actually applying. It seems like the socket right here, or the cup that holds that whole assembly, can be moved in. There's actually a screw right here that goes through here, and there's a slit in this metal right here. So if I loosen this screw, that's going to open up that enough so that I can actually, this will loosen up, and I could actually slide this in or out as necessary. I could take it out to change the brush, or I could even put it in a little bit further than it already is to try and compensate for the wear. But I think what I'm going to do is I'm going to take that out so I can examine this whole thing. I decided I'm not going to take this screw off because it's stuck to the terminal. So the terminal wants to turn with the screw, and I'm worried if I put too much force on here, I'm going to crack this what's more than likely Bakelite cup. So I'm going to leave that alone. So next question is, how do you loosen this screw? Well, it's an Allen head cap screw, so it actually should be pretty easy to get to. I do notice the ingenious design here. They actually have it so that when the pedal is fully depressed, the head of that cap screw actually sticks up through a hole right here. So it's almost like it's a service hole, so that you can maybe loosen that screw without taking the whole thing apart. Although I don't know what good that would do you. So that's in there pretty tight. I completely removed the screw, and then what I did was I just drove a sharp point into the gap there, and that's spreading that up enough now so that now I can actually kind of move this, twist it a little bit. Should be able to get it to come out. There we go. Now you can see the anatomy of the beast. Not unlike a brush holder in an electric motor. We've got a little brush, and it's spring loaded. The brush even has a part number on it, 671. Alright, so I removed the brush, the brush holder, and looking at the end of the brush, I could see that there was just some small marks on it, but it didn't actually look too bad. So I took a little bit of emery, and I just cleaned up the end of the brush a little bit. And then I used an old toothbrush and my Pro Gold contact enhancer. This is a deoxidizer, and actually cleaned this whole area right here. Then I reinstalled the brush, and I moved in the holder so that there's more preload, so to speak, on that brush. And I'm going to retest and see whether or not that has improved the situation or made any difference at all. Oh my, big difference. So now, when the brush is in the parked position on the end here, I'm getting pretty much zero resistance, which is wonderful. And as I actuate the pedal, you can see the resistance is going up 4 ohms, 5, 6, 7, 8, 10, 12, 13, 14, 15, and that's pretty much floored right there. That's where the brush is actually parked on the opposite end, which would be the full resistance of the resistor. And again, I'm going to come back down. Oh yeah, that's working really nice now. It's working the way I would expect it to work. So we go from 0 ohms, and we have a gradual increase as I step on the pedal and push it all the way down to a maximum of right at the end there we got a little bit of about 20 ohms. So I would call that a successful repair, and I lucked out there. Now, obviously, if I had opened this up and this big resistor was damaged, had big arc marks on it, or if it was open, then we'd be in a world of hurt. At that point, you would have really no alternative other than to either try and find another pedal. Of course, if you find a pedal used online, you don't know what kind of condition it's going to be in, but you could always, if it works at all, then you get a better chance of rejuvenating it. The other possibility is, if you have no luck there, I would try and find a device like a rheostat that has a high wattage rating and has a overall resistance of about 20 ohms, and then figure out a way to mount that in here and use some sort of a maybe a cam to actually actuate it. So instead of going to this type of setup here where this tap just moves along the side of this resistor, you would actually have a more conventional rheostat. You know, maybe something along the lines of this here. So this basically does the same exact thing, only you see that they've basically wrapped this in a circle, and as this arm rotates around, there's almost like a brush there that comes in contact with different positions. Probably could be a way to actually modify the pedal so that it actually made this rotate easy enough. And this is rated at 20 ohms, 150 watts. Now I've got it pretty much all reassembled except for the bottom cover being back on, and I'm going to do the same test. I'm going to do it with the connections actually at the plug itself. So now I'm taking into account the resistance of the cabling and everything, and with the pedal in the undepressed position, I'm getting about 4.5 ohms, which is, again, that's the resistance of that wiring. And when I depress it, actually drops down to about 2 right when the switch closes. That's when I'm just coming right off of that little parked area there and onto the first part of the resistor. So it's actually making a little bit better connection on the resistor winding itself. And you can see as I slowly depress the pedal, the resistance slowly and evenly creeps up. So it's acting a lot better than it was. And I'm almost all the way full pedal. It's a little erratic right there at the very end. I'd be willing to bet though that that's still going to be serviceable just in that condition, just the way it is. Considering how much mouse poop fell out of this thing, it's no wonder that it was acting a little erratic. Next up, I'm going to open up that pedal just to see whether or not the construction is identical. I suspect it will be. If not exactly the same, it'll be very similar in construction. Probably do just a quick cleaning on that one too. Alright, so here's the inside of the blue pedal, and as I suspected, it's virtually identical in construction. The switch over here is the same switch. The resistor looks very similar. It's a square-shaped wire-wound resistor. The electrical resistance measurement of that resistor is about 15.6 ohms. The brush holder looks a little bit different on this one. Okay, so this is a little bit different construction here. What we've got here, not positive, but that might actually be a push-on terminal. Sure is. That's a push-on 1/4-inch spade terminal and connector. Huh. And I'm wondering whether or not this back piece actually comes off. There might be a way that this actually opens up in the back so that you can change the brush without having to remove this screw like I did on the other one. Huh. Well, I'm not going to force it. I'm going to leave it alone. So I did an electrical resistance check of this one, and this one works a lot better than the other one did before I fixed the other one, but it's still, you know, could use a little bit of attention. But I think instead of taking the brush out on this one, I'm going to leave it together, and I'm going to just use some of this contact cleaner on it. That looks pretty good. Well, I practically have to, I think I'm actually touching the metal to initiate the arc, so I can hear the high frequency working, but it's not really doing anything. But there's a high frequency intensity control that I haven't touched, so I'm thinking I might try and turn that up. And then when I did initiate an arc, it didn't look like it was doing much to me, so I floored the pedal, and when I floored the pedal, it didn't take long to burn a hole right through this metal. Okay, so I got two things going on here. Shut the cooler off so you can hear what I'm saying better. But two things going on here. First thing is, I'm still not getting any high frequency start, although clearly from the activity over there at the spark gap, there's plenty of high frequency being generated over there. So I'm not quite sure why this isn't working. I tried that control, I turned it all the way up to 100, still no high frequency. Then when I finally did touch off and get it to start, and I eased off on the pedal so that I could see the plasma ball more clearly, I was looking at it, it was looking kind of weird to me. And then it suddenly struck me, I never turned on my argon supply. So I've been doing all this with no shielding gas. Alright, let's try this again with some argon.